So if you remember that we talked about at the very beginning how the Black Forest fire in Colorado back in 2013 was managed reasonably well due to experience. Well, part of that experience comes from the knowledge of well, at least three different aspects of wildfire: the type of fuel that is there, the topography of the land, and also the weather conditions that could contribute to or cut back on that fire. So understanding these three factors really helps us to be able to predict what's going to happen with wildfires. In the other fire in 2013 outside of Yarnell, Arizona, very, very erratic weather conditions and topography as well, and so it really caught the firefighters off guard, which is why so many of them, 19 of them were killed. That it's not that they didn't understand these processes, but these processes were very unpredictable, and so it caught a lot of them off guard. So depending on what kind of fuel there is, it'll determine what sort of rate at which the fire burns. Obviously, different types and different sizes. Maybe one type of fuel burns more readily than others. The more moisture content there is, that means that it's less prone to burn. So the less moisture there is, it'll burn more rapidly. And so you got like smaller stuff like dried out leaves and twigs. That stuff burns very easily. If you build a campfire, all right, you would collect these and you'd probably call them kindling. All right, you're kindling a fire. You're getting real lightweight stuff to be able to burn. All right, it can also take place, or it can also take the form of possibly even peat. Now, peat is kind of a really low-grade type of coal that is made from biological material, decayed stuff like swampy biomatter that is dried out. Now, that wouldn't burn right away. That would be kind of a fuel later on. But you can almost think of it as chunks of mulch, if you would. All right, and mulch, if it dries out, you can burn it pretty well. But all these are different types of fuel. If any of you have a wood stove at home, I don't know many. Well, I used to when I was a kid. I don't know many people who do anymore. But if you have a wood stove, you may find that people tend to like to burn oak, or other hardwoods, or like maple, rather than pine, or other. I'm trying to think of another kind of a soft wood. Well, we'll just compare it to pine. All right. These are all types of wood that come from mature trees, but pine has a lot of sap in it, has a lot of tar, has a lot of moisture. All right, and even when it is dried out, it doesn't have as much chemical energy in it as these hardwoods like oak and maple. These are harder to get going, but once they are going, they release a lot of energy. So these are different types of fuel that, even by the very nature of the trees themselves, have different kind of combustion properties. So the fuel size certainly affects ignition, but also the fuel type, what kind of trees, what kind of shrubbery, what kind of vegetation is around, how dry is it. All these things determine the rate at which combustion takes place. All right, topography, another big one. All right, we mentioned how in Yarnell, Arizona, topography played a part. Let's see, let me draw just kind of like a hillside right here. What topography does is it determines how well, how quickly, I should say, the wildfire progresses. Let's say you've got a mountainside with trees on it right there. All right, well, right here, if our fire is taking place in the valley, it's going to be kind of very easily preheating those trees. All right, so the degree to which the land is sloped, that is the topography, can help contribute to that. The other thing is that what valleys tend to do is they tend to circulate, or they tend to sort of channel wind. All right, they channel wind through valleys, and so if you've got a wildfire in a valley or up a slope, it can serve as almost like a channel or a groove where air can come in and feed that fire, making it easier to spread. The other thing about topography is, I guess it may even seem more obvious, is that maybe not the shape or the contours of the land, but where the land actually is. For example, is the land in Arizona, okay? Or is the land in, I don't know, let's say Maine, okay? Maine being kind of a northeast, cooler, maybe more humid state. Arizona being a southwest, drier state. Obviously, Arizona is much more likely, just by the nature of its topography or its location, to have fuel that is ready to burn. All right, so all these are elements of topography that contribute to how fast a fire will burn itself. And finally, weather. Weather plays a big part. Obviously, if it's raining, you've got less of a likelihood of fire. Where you've got droughts and just general low humidity, you have much more possibility for a chance for fire because you don't have that water or water content in the fuel that needs to be preheated first. Preheating, it goes much more quickly if you have no water, or very little water content in the fuel. All right, so droughts. Wherever there's a drought, you've got a really, really high likelihood of wildfires. Lightning, here it's actually spelled correctly, right there. Thunderstorms, in many cases, are associated with wildfires because of lightning. But you might think, oh, a thunderstorm, why wouldn't the rain put that out? Well, sometimes we can have dry thunderstorms, all right? You can have thunder clouds, you can have cumulonimbus clouds with lightning without any rain actually falling. And so if there's no water being dropped on the ground, but you do have this heat from the lightning, that's a real kind of great ignition point that can start off wildfires. All right, so maybe even if it does rain, but it's been so dry that the water evaporates. That happens a lot in the Southwest. Wildfires are likely to take place. All right, when humidity is lowest, obviously less water vapor in the air, less water to boil out or pre-ignite, and so those are all elements of water that contribute to or kind of detract from wildfires. Wind direction. Of course, right? You need oxygen coming in to sustain a fire, right? Where the wind comes from, or if there is a supply of wind or fresh air coming in, that'll sustain a wildfire or possibly put it out if you don't have a good source of air coming in. And also, the winds, what they do is they carry burning embers elsewhere and allow pre-ignition to take place at other spots, maybe even jumping over. So a fire doesn't need to spread in one big blob. I guess that should be red, I guess. Or orange, there we go. A fire doesn't need to spread in one big blob, but it can actually jump. Winds can carry it up and over and drop right here, and then that can spread. So winds carrying embers also pose a real threat, not just to the fire that is burning, but they create the chance of other fires being set elsewhere. All right, so we're going to finish up the section looking at three different types of fires, three different types of, you might say, forest fires or wildfires that could be in grasslands, and the first of which is called ground fires. All right, now these, they don't really get maybe as much press as some of the other ones because there's little flaming taking place. It's just more smoldering. Energy is being released. Chemical reactions are taking place, but they look more like this. All right, so there are some flames right there, but what you can't see is that there's smoldering taking place in many of these areas right here where you don't see the flames. So you think you see some flames here and kind of like separated a little bit. That's not as there's more going on there than it really looks like is happening. Go back here. All right, so you have decaying organic matter in the soil. We'll call that duff. All right, that's what's burning. Where you have swamps and marshes. Remember, I talked about how peat is really decaying marshy material. Well, if that's dried out, if it's been drained out, all that decaying material, it makes really, really good fuel. But that's in the ground, and so that takes place in ground fires. Like I said, I mentioned peat before. All right. Okay, we also have now surface fires. All right, surface fires are what take place not just on the ground, but they start to actually climb up the trunks and the stalks of trees and bushes, and these produce a little bit more flaming. Not a whole giant inferno, but maybe bigger sized pockets of flaming taking place. Definitely with some smoldering, but more flaming than with ground fires. All right, so grass and shrubs, dead and down trees. This right here would be a surface fire. All right, a lot more going on right there. Not just little patches of fire creeping along the ground, but much considerably more flaming taking place. All right, and a third type of wildfire is called a crown fire. Crown meaning like the top of something, like the crown of your head, or in this case, it would be the crown of trees. Here's where you've got the flames that have gone all the way up the trees and are burning in the canopy itself. All right, so it may go all the way down to the ground. It's not just in the canopy, but it reaches the canopy of trees and goes even higher, as you can see right there. Strong winds really play a part because you don't have the trees. Well, the flames are high enough that the trees can't block the winds, and so winds really play a part to add oxygen to that mix and keep the fire going. So that's going to be it for our section 2. Section 2 is kind of a longer one right here. We're going to look a little bit later on at the geographic elements that are susceptible to fire. But for now, we're going to call that a section. And if you have any questions, please make sure you come see me. Either way, thanks for watching, and I'll see you on the next video.